Okay. Do here, what we have is something like, imagine this. So this is some spring thing like this in here, and then there's a ball like that. And then so the ball shoots up in the air. Does that make sense to you? Okay. So then what I'm going to do is I'm going to say KE, oh, just kidding, MEI, jeez, equals MEF. Now, what kind of energy does this have in the beginning? Potential of what? Very good. Of a spring. And what kind of energy does it have when it's at the very top and stops? Potential energy of gravity. So then here, I get 1/2 K x squared equals mgh. Now, be careful, because this is plus x. Because where did the ball start from? Yeah, it started at the very, when the spring is all the way compressed, that's where it starts from. Otherwise, you have to take the PE and convert it into KE. And then go from KE into PEG. Do you see what I'm saying? The ball, the change in potential energy for this ball is from the lowest point where it started to the highest point where it stopped. But we know that, so that's not a big problem. So we're going to get 1/2 K x squared equals mgh plus mgx. And so we say h is equal to kx squared over 2 minus mgx over mg. I'll raise that up. I get of basically 0.214 meters or 21.4 centimeters. I don't care which answer you give me, as long as you give me an answer that is not naked. Naked numbers are cold, lonely, and afraid. Don't do that. Okay, so for this one, the second part, part B, if the barrel has that, then what happens? Well, what we're doing now is we're saying MEI equals MEF plus work done by a non-conservative system. Okay, so here, then, this one, I should have listed that the barrel's horizontal. That should have been horizontal. That's annoying. I apologize. That creates a big problem. It has to be horizontal. And so anyways, we start with the initial energy is PES for spring. This is going to be KE, obviously. And then this is the work done by friction. The reason the barrel has to be horizontal is so that when you can calculate the work done by friction. Because that's going to be mu mgd. So, yeah, if it's straight up, how do you calculate the friction? You know what I mean? In the barrel, you don't know what force the barrel applies to the ball. So this is 1/2 kx squared. Please tell me I'm recording this. Yes, thank you. Is equal to 1/2 mv squared plus mu mgd. And we're looking for the velocity of the ball. So we're going to say 1/2 mv squared is equal to kx squared over 2 minus mu mgd. And so then we get v is equal to the square root of, we're going to get kx squared over m minus 2 mu gd. Yeah, so for the ball, there's FG and FN. Does that make sense? Okay, there's also like FS right here, but does this make sense? Okay, and so then FF goes back like that. So FN's up, FG's down, FS is forward, FF is backwards. FF is mu FN, and FN is FG. So FF is mu F sub G, and F sub G is mg. So I get mu mg. FF is mu mg. And what is the work done by friction? It's the force of friction times distance. So this right here is F sub F. And that's how we get to that. I get a velocity of 1.61 meters per second.